China's Atomic Energy Authority has announced that the country has nearly completed construction of a power plant with the world's most advanced nuclear reactor.
And China is poised to revolutionize the nuclear energy landscape. The Asian giant wants to build the world's first thorium-based molten salt nuclear power station, a development that could reshape global energy production.
Far from the spotlight, deep in China's Gobi Desert, something groundbreaking just fired up, quietly but powerfully. China has flipped the nuclear playbook and brought to life a technology the U.S. first explored nearly 80 years ago, then abandoned. This isn't another uranium reactor. This is thorium, molten salt, low waste, and built for a safer energy future. While most nations cling to the old ways, China may have just pulled ahead in the global energy race, and barely anyone's talking about it. Back in the atomic heyday of the 1950s and 60s, a little-known element almost rewrote the rules of nuclear energy: thorium. Silvery, soft, and hiding in plain sight within common beach sands, this metal had the potential to revolutionize how power was generated. It was cleaner, safer, and nearly impossible to weaponize. No mushroom clouds, no decades-long waste, no Cold War boogeyman built into its chemistry, and the U.S. knew it. At the Oak Ridge National Laboratory in Tennessee, a group of brilliant minds got close, real close. They built a working prototype reactor that ran not on uranium, but on thorium. It was called a molten salt reactor, and it worked like a charm. But as the Cold War intensified, energy policy stopped being about science and started being about strategy. The military wanted dual-use tech. If a reactor couldn't contribute to the weapons program, it was quietly sidelined. Thorium had one fatal flaw in that era: it couldn't help build bombs. Unlike uranium or plutonium, thorium had to be converted into a different isotope, uranium-233, before it could even produce energy. That extra step made it useless for immediate weapons manufacturing. So even though it was safe, efficient, and practically immune to meltdowns, it didn't get the nod. The world doubled down on uranium. Contracts were signed, suppliers lined up, and thorium was shelved like a forgotten draft of a better future. But that decision shaped history. Thorium produces significantly less long-lived radioactive waste. Its byproducts decay in a few hundred years, not tens of thousands. And most importantly, reactors using thorium wouldn't spiral into disaster the way traditional uranium reactors could. It was a chance to build a clean, meltdown-proof nuclear industry from the start. Instead, it became a missed opportunity. Fast forward to the 1990s, and things start to stir. Much of the old Oak Ridge research was declassified. All of it, blueprints, technical notes, reactor data, suddenly became public. It was no longer state secret material, it was up for grabs. And while the West mostly shrugged it off, one country was quietly paying attention. The molten salt reactor design that Oak Ridge had perfected decades ago was about to find new life halfway across the world, in the vast, silent stretch of China's Gobi Desert. The reactor that broke the rules. Molten salt reactors are nothing like the giant water-filled behemoths most associate with nuclear energy. No pressure chambers, no steam explosions, no fuel rods melting into disaster. The idea was radical. Dissolve the nuclear fuel directly into a bath of molten salt. That liquid would flow through a reactor core, heating up and generating electricity without the high pressure and risk. And it came with a fail-safe that felt more like science fiction than engineering. At the base of the reactor sat a frozen salt plug. If the system lost power, whether from a cyber attack, earthquake, or sabotage, the plug would melt and the fuel would naturally drain into underground tanks. The chain reaction would stop cold. No meltdown, no Chernobyl, no Fukushima. Just a quiet shutdown triggered by gravity and chemistry. The Oak Ridge team ran one of these reactors for years. It worked perfectly, but it was abandoned anyway. Not because of failure, but because it didn't play into the arms race. There was no plutonium to harvest, no bombs to build, and by then, the U.S. was too invested in uranium to turn back. China saw the value in what had been left behind: China's silent desert breakthrough. Far from Beijing's political bustle, in the lifeless stretch of the Gobi Desert, a quiet hum began to echo through the sand. No ribbon cutting, no big announcement, Just an operational thorium molten salt reactor, quietly reaching criticality in October 2023. The world's first of its kind, TMS-RLF-1. The name sounds more like a code than a revolution, but make no mistake, this reactor flipped the script. Fueled and cooled by molten salt, air-cooled instead of water-hungry, and perfectly suited for arid, remote areas, it marked a turning point. And in 2024, it pulled off a nuclear industry first. It was refueled while still running. No shutdown, no restart, just uninterrupted clean energy. This wasn't about powering cities. It was about proving that molten salt reactors work, that thorium is viable, that the vision abandoned in the 1960s wasn't a dead end. It just needed someone bold enough to follow through. The man leading the charge was Dr. Xu Hongjie, a physicist from Shanghai. What began with a small team exploded into a 400-person operation. They dug through dusty archives, modernized designs, solved corrosion issues, and built something the West never finished. And they did it all with little media fanfare, just results. Why the Gobi Desert? The remoteness made sense. Less interference, more control, but it was also symbolic. In a place where nothing grows, China planted the seed of an energy future others abandoned. Scaling up, the next phase. The prototype wasn't the end goal, it was the green light. Now comes the ramp up. The Chinese playbook is familiar. Prove the concept, then scale hard and fast. It worked for solar, it worked for high-speed rail, it worked for EVs, and now it's thorium's turn. Next on the list, a 10-megawatt electric reactor by 2030. Not just experimental, this one's meant to power the grid. More importantly, it's modular, designed to be built in factories and shipped out like a product, not a construction project. Small enough to fit in containers, powerful enough to run small cities or remote industries. These reactors aren't bound to land either. Thorium-powered cargo ships are already being sketched out, massive vessels crossing oceans, never stopping for fuel, never spewing carbon. Offshore installations, remote island bases, disaster zones, they're all part of the roadmap. But it's not just about replacing coal or oil. Thorium reactors are being designed to work with renewables. Paired with solar and wind farms, they'll smooth out the gaps, cover dark nights, and keep grids stable when the weather doesn't cooperate. The quiet shift in global power. In past decades, energy dominance meant controlling oil fields and pipeline routes. But the world's shifting. Fossil fuels are falling out of favor, and electricity is taking over. And the countries that master the next generation of power infrastructure, they'll shape everything, from economics to diplomacy. Thorium offers a cleaner path. No uranium enrichment, no weapons-grade material. It's perfect for nations that want nuclear power without the baggage. In China, it's stepping in with a deal. Thorium reactors as a service. Financing, training, grid integration, wrapped up and delivered, ready to go. Countries like Kenya, Nigeria, Laos, and Pakistan are already in talks. The appeal is obvious. Thorium reactors bring electricity, sure, but they also bring Chinese engineers, Chinese safety standards, Chinese influence. They create dependency, not through military bases, but through energy. A thorium reactor in rural Kenya doesn't just light up homes. It ties the region into a new energy order. One not led by the West, one not watched over by Washington, but one that hums quietly in the sand. Like the reactor in the Gobi, the future of power may not come with explosions or headlines. It may come silently, glowing, molten, and unstoppable. But why the West let go of the future? In the Cold War rush, weapon potential mattered more than sustainability. Thorium couldn't help build an arsenal, so it was shoved aside. And when the Cold War finally cooled off, it was too late. Entire industries were already locked into uranium-based designs. Supply chains, regulations, reactor blueprints, all of it catered to the old ways. Changing course would have meant reworking everything from engineering programs to federal law. So America stuck with what it knew. Today, that decision casts a long shadow. China just fired up its first working thorium reactor. Meanwhile, the US struggles to finish uranium plants on schedule, if they finish at all. There's not even a solid licensing process for molten salt reactors. Startups trying to push innovation face a wall of bureaucracy. The West had the lead once. Now it risks falling behind. Because thorium isn't just a science project anymore. It's the new front line in global energy. In China, it's already building the playbook. The question isn't whether the world will follow, it's who gets left behind when it does. What do you think? Tell us in the comments below. Thanks for tuning in, and see you in the next one.